Hello students, welcome back to my channel NJ Math World. Today I am here to solve model question paper 1 of discrete mathematical structure, second BCA, second semester BCA, NEP syllabus, BNU. So yeah, we are going to solve the question paper which carries 60 marks. Time duration of the question paper is 1.5 mark and we have to answer all the questions. So in session 1, we have 2 mark questions. We have to answer any 6 questions of 2 mark. So the first question is, what is a proposition? Give 2 example. A preposition is a mathematical statement which is either true or false but cannot be both. So either the statement should be true or it should be false. It cannot be both. If it is both, then it is not a preposition. For example, Bangalore is a capital of Karnataka. It is a true statement, hence it is a preposition. The second one is, what is a modus ponens rule of inference? The modus ponens rule of inference is a fundamental principle in logic and reasoning. It is a form of argument what we have, and it states like P implies Q. If P implies Q, then P is true. If P implies Q, P is true, then Q is also true. That is, P implies Q, comma P gives you Q. It's called as modus ponens rule. So moving with the next question, question number 3, find the determinant of the given matrix. So to find the determinant of the given matrix, we need to write the matrix in the form of determinant. So yeah, we'll be taking plus, minus, plus. Always when you want to find determinant, we'll consider it as plus, minus and plus sign. So you will be taking first element of the row, that will be plus 3 will be, you leave that row and column, your answer will be 1, minus 2, 3 and 4. Then we'll go for the second element of the first row, that will be minus 2. That row and that column you should neglect, it will be minus 2 into 0, minus 2, 1 and 4. Then you'll go for the third one, which is considering the third element of the first row. You'll be simplifying only first row elements for finding determinant. So it is plus 1, it will be 0, 1 and 1 and 3. So you have to simplify this, it will be plus 3. That it will be 4, you have to cross multiply, 4 ones are 4. Always you'll have minus sign. Then this 3 into minus 2 is minus 6. So minus and minus become plus, it will be plus 6. Then it is minus 2. Here 0 into 4 is 0. Minus is common. This 1 into minus 2 is minus 2. Minus of minus become plus. 2 ones are 2. Then plus 1 it is 0 into 3 is 0. Minus 1 into 1 is 1. So yeah, it will be plus 3. 4 plus 6 is 10. Minus 2. 0 plus 2 is 2. Plus 1. It will be minus 1. So yeah, 10 threes are, it is 30, minus 2 twos are 4, minus 5 1 ones are 1. So if it is 30 minus 5, it is 25. So determined value of the given matrix is 25. Now moving with the next question, in how many ways 4 boys can be seated on a bench? So here the value total number of boys are 4. Arrangement to be done in only one bench. So it will be NPR. NPR is n factorial divided by n minus r factorial. So n factorial is 4 factorial divided by 4 minus 1 factorial. So yeah, we can write 4 factorial divided by 3 factorial. That will be 4 into 3 factorial divided by 3 factorial. Then 3 factorial cancel, it will be 4. Or we can have another formula, np1 equals n. We can use the formula directly. Then moving with the next question, give the recurrence relation for the factorial number. So here recurrence relation of a factorial number will be n into n minus 1. We'll just see how would we get. If n is 0, we get 0 factorial is 1. If n is 1, we get 1 factorial is 1. If it is n is 2, we get 2 factorial will be 2 into 1. that can be written as 2 into 1 factorial. Then if n is 3, we can write 3 factorial, that will be 3 into 2 into 1, that can be written as 3 into 2 factorial, 1 factorial. Then if n is 4, we can write it as n factorial, 4 factorial is 4 into 3 into 2 into 1. We can write that as 4 into 3 factorial. You can see in the last, if it goes on, so here it is continuation number 1, 2, 3, 4. So it will be n. Continuation number will be n into, now if it is 4, it is reducing 1, means if it is n, it reduces to 1, means n minus 1 factorial will be the general recurrence relation for the factorial number. Then moving on with the next question, what is mean by program correctness? Program correctness refer to the assurance that the program behaves as intended, fulfilling all specific requirement and producing the correct output for all possible inputs. So we have different method. First is called formal method. Second is inclusive, including proofs and logical reasoning. This, by using these three methods, we can find the program correctness. Then moving with the next one, reflexive relation. What is reflexive relation? A relation is said to be reflexive if it is having a comma a belongs to R. That means if a is 1 comma 2 comma 3, for the reflexive relation, we can write 1 comma 1. The element should be related to itself. That is, 1 will be related to 1, 2 will be related to 2, 3 will be related to 3. Therefore, 1, 2, 3 is related to itself. So it is called as reflexive. Then moving on with the next one, what is a planar graph? Give an example. A planar graph is a type of graph that can be drawn on a flat surface, like a piece of paper, without any of its edges crossing each other. So, if it is crossing each other, if it is crossing each other, then it is not said to be planar. So, any non-planar graph can be converted into planar by removing the cross edge which is present in there. If it is a b c d, a b c d, so we can remove the edge which is there from b to d, we can connect it from outside. So here it becomes a planar graph. Planar graph is a graph in which no two edges cross each other. So any non-planar graph can be converted in the form of planar. Then moving on with the next question, we have write the converse, inverse, and contrapositive of the given statement. So they've given the home team wins whenever it is raining. So yeah, it is the first question. Let us take it as P, the home team wins, and Q, it is raining. So here P implies Q is if home team wins, then it is raining. Now we need to find the converse. What is the converse? Converse of the statement switches the order of P and Q. So it will be reverse of P and Q. So Q implies P. If it is raining, then hometown wins, home team will wins. Then inverse, the inverse of the statement inverts both P and Q. We have to write negation P and negation Q. Negation means it is not, so we will use not for both the statement. If home team does not win, then it is not raining. Then next one is contrapositive. The contrapositive of the statement switches the order of P and Q and negates both. It is a reverse of inverse. So here negation Q implies negation P. If it is not raining, then the home team does not win. So yeah, moving on with the next question. Find the compound proposition is given and they're asking you to find it as a logically equivalent. So we have P Q, then we have P and Q. Then here we have P P or Q, then P or R, then both with and. So we will find it here. It is T T T T F F F F, 4 times T and 4 times F. Then you should write 2 times T and 2 times F, 2 times T and 2 times F. Then it will be 1 time T, 1 time F, 1 time T, 1 time F, 1 time T and 1 time F. Now and is nothing but, and the condition is if it is T and T, it is T. If not, it is false. So here we have to see for Q and R. Q and R. This we can take it as small r. Q and R here. If it is T and T, it is T. So first one is T and T, it is T. Then you have a T and T, it is T. The remaining all is false. Now we will be checking for P and Q and R condition. So here we are checking for or. Or is if it is F and F, if it is false, otherwise it is true. Now we will be checking for F and F. So F and F for this, it is F and F. Here we have F and F, it is F. F and F, it is F. F and F, it is F. So this is your LHS. Now we'll go on with the RHS. We have P or Q. P or Q means or is what? F and F, it is F. So you will be checking for F and F. F and F for P and Q. So we have F and F in the last two. That is F and F, F. Then we'll go for P and R. We will be checking it for P and R. P and R, we will be checking again for R. P and R, F and F. We have it here. F and F, it is F. Then the last one, F and F, it is F. Otherwise, it is true. Then we'll be checking now for this both. The condition is and T, it is true. We'll be checking for T and T, it is true. Okay. So yeah, it is T and T, yes, true. T and T, it is T. 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 Then T and F, it is F. F and T, it is F. F and F, it is F. Therefore, now compare both the answers, that is this answer and this answer. If the answers are similar, means they are logically equivalent. Therefore, it is logically equivalent set preposition. Now, next moving with the next question, find the function x plus f of x equals x plus 1 for the set of integers is onto. So proof, let it is onto, let x belongs to z, there exists y belongs to z such that f of x equals y. So now what is f of x? They have given x plus 1 equals y. Then it will x will be y minus 1. So here, therefore, f is onto. F is onto. Next question is find how many arrangement can be made with the letter mathematics. In how many ways of them math D occurs together. So they have two questions they have asked. First one is they are asking you to find how many letters are there in a mathematics, and then second question is asked is how many, if you take this THE separately, how many letters are been there. So yeah, first we'll find it for mathematics, that will be in how many ways arrangement can be made for the letter mathematics. First one, so MATHMATICS, mathematics. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So it is 10 factorial divided by. So you have to see how many letters are repeated. M is repeated 2 times. M 2 times. Then it will be 2 factorial. Then A is repeated 2 times. A is repeated 2 times. It is again 2 factorial. Then it is T is repeated 2 times. It is 2 factorial. T is repeated 2 times. It is 2 factorial. So yeah, then no other elements are repeated. Then it will be what? It will be 10 into 9 into 10 into 9 into 8 into 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial divided by 2 factorial, 2 factorial, 2 factorial. 2 factorial is nothing but 2. I will write it as 2, 2 and 2 factorial. 2 factorial cancel. 2 2s are 4 and 4 get cancelled. So if you multiply 10 into 9 into 8 into 7 into 6 into 5 into 3, you get 4 53600, 4,53,600. So this is the first part. Then in second part it says, when you take mathematics and the is kept as one element. So here one letter the is separated, then it will be m a the we are removing from here, it will be m a TICS, mathematics. So this will consider 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it will be 9 factorial divided by, again here m is repeated 2 times, m 2 times. So it will be 2 factorial. Then a is repeated 2 times, 2 times. So it will be 2 factorial. Then we don't have a t, one t is gone, so it will be 9 factorial, 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 divided by 2 factorial into 2. So here factorial get cancelled, 2 ones are 2 twos are. When you multiply all these numbers, you get it as 3 6 2 8 8 0. Now when we have taken this the separately, we have to find the answer for that and then multiply with the final answer the. So there are three letters and three letters are taken at a time. That will be 3p3, that will be 3 factorial, n is n factorial. So 3p3 is 3 factorial, that will be 3 into 2 into 1, that will be 6. Therefore total number of total total arrangement together total arrangement meant together is 362880 into 6, that will be 2177280 ways. So moving with the next question, we have find the joint and meet of the zeros of the matrix. What is joint and meet? For joint and meet, we need to find, joint is nothing but and operation. Joint means and operation, and operation, but it will be written as joint means it is and operation. That will be p q p and q, that will be 0 0 1 1, 0 1 0 1, and is what, 1 1 it is 1, remaining all will be 0. It is for and, yeah, but here there will be one change for and, operation will be for and, but you will write it as 0 1 0 1, it will be reverse order. For joint it will be 0 0 0, the remaining all will be 1. It will be, operation will be of or. Then meet is nothing but, meet is or operation, and it is represented or, but here operation will be reverse, 0 0 1 1 0 1 0 1. If it will be ff, it is 1 1, it is a 1, remaining all will be zeros. So now by keeping this, we need to prove the operations of this two, that is a and b. How do we prove this a and b? So it is 1 0 1 0 1 0 and 0 1 0 1 1 0. And operation says what? And is, yeah, it is 0 0 0, remaining all it is 1. So yeah, it is 1 and 1 1, 0 and 1 1, 0 1 and 0 1, 0 and 1 1, 1 and 1 1, 0 and 0, it is 0 for AND. Then for OR operation, that is joint. Then meet is 1 0 1 0 1 0 or 0 1 0 1 1 0. So here reverse we have to will be writing it reverse, that will be 1 and 1, it is 1, remaining all 0. So we'll check it for that. It is 1 and 0, it is 0. 0 and 1 is 0. 1 and 0 is 0. 0 and 1 is 0. 1 and 1 is 1. 0 and 0 is 0. So this is the meet operation. Then moving with the next question, application of inclusion and exclusion. Few application of inclusion and exclusions are scheduling tasks and meetings to avoid conflicts, calculating the number of unique items in overlapping set such as survey responses, determining the probability of at least one of the several events occurring, then managing overlapping responsibilities or roles in a team, allotting resources or budgets across overlapping projects or departments. So these are the few applications of inclusion and exclusion. Then moving with the next one, we have find the Warshall's algorithm. So Warshall algorithm is very simple and easy to understand. So here we will take this as 1, 2, 3, 4, 1, 2, 3, 4. So yeah, I'll just check and write what are the given here. 1 and 1 is 1. We have a relation of from 1 to 1. Then it is 1 to 4. 1 to 4 I have a relation. Then 2 to 1. 2 to 1 I have a relation. 2 to 3. 2 to 3 I have a relation. 3 to 1 I have a relation. 3 to 2 I have a relation. 3 to 4 I have a relation. 4 to 2 I have a relation. The remaining all will be zeros. So here the same thing we can write it in the in the form of matrix, that will be A B C D and A B C D. We can take it as 1 0 0 1, 1 0 1 0, 1 1 1 0, then 0 1 0 0. That will be 0 1 0, 1 1 0, 1 0 0. So yeah, this can be drawn as A B C and D. So we have A B C D. Diagram for this given Warshall is A to A I have one, A to A you have a self loop, A to D I have one connection from A to D. Then B to A I have one, B to A I have one. Then B to C I have one, B to C I have one. Then C to A I have one, C to A I have one. Then C to B I have one, C to B I have one relation. Then C to C I have it, so it will be self loop. Then D to B, D to B I have one, D to B one relation. Then D to, that's it. So this is the given relation diagram. Okay, so now we have to find the Warshall algorithm for this. How we are going to do Warshall algorithm? Follow the steps. Okay, the step 1, that is the given matrix will can be written as R naught. R naught will be whatever you have, that will be called as R naught. That will be, this you can call it as R naught. Okay, so now R1 I will take. R1 will be A B C D, A B C D. So yeah, I have 1 1 1 0, 0 0 1 1, 0 1 1 0, 1 0 0 0. So that is first one. Now what we are going to do is, you will be selecting the first row and you'll be selecting the first column. So we are selecting first row. Now you see in first row, where are the element 1? 1 is there in A place, A, so we'll write it A. 1 is there in D place. It is there in D, so we'll write it in D. Then C1, you'll take C1, column 1. 1 is there in place of A, in place of B, in place of C. So we'll write C1 is A, comma B, comma C. Now you have to find the cross product of these two. R1 cross C1, that will be A, comma A, A, comma Cartesian product A, comma B, A, comma C. Then it will be D, comma A, D, comma B, D, comma C. So now, what are the elements we got? New elements. We will write it in the R2. That will be operation 2. That is 2. We'll write the elements what we have received now. That will be here. It is A, B, C, D. A, B, C, D. So first you write down what is there. A and A is 1. A and B is 1. A and C is 1. Then D and A is 1, D and B is 1, and D and C is 1. The remaining numbers what we have, write it as it is. So I have it on D, I have it on B, I have it on C. Then here I have here for second line it is 0, 1 and 0. Then third line it is 1, 1 and 0. Then fourth line it is 0. So this will be a new matrix. Now in the new one what we are going to do, we are going to select the second row and second column, second row and second column, R2. So now find for R2. For R2, where are the elements we have? It will be for A, it is for C. So it will be A, comma C. Then for C2, where are the elements for C2? That will be, it is for A, then we have it for C, and we have it for D. That is C2 is A, C and D. Now find the Cartesian product of these two. C R2 cross C2, that will be A, comma A, A, comma C, A, comma D. Then C, comma A, C, comma C, then C, comma C, comma D. So here we got the new one, new element. So where we will be writing this new one? We'll write it in the, I'll write it here. So it will be R3. R3 will be the new matrix what we got. It will be A, B, C, D. Here it is A, B, C, D, R3. So A is it is 1 1, A 1 1, C is 1 and D is 1. Then B is we don't have. Then for C it is C of A is 1, C of C is 1, C of D is 1. The remaining one will copy from here. It is 1 1 1. It is whole first line is 1 1 1. Then it is on the top is also 1 1. Then we have 1 0 1 0, 1 0 1 0. Then here it is 1, and here we have the last one is also 1 1 0. So this will be your third step. Now fourth step, what next step what you are going to do, we are going to select the third row and third column, third row and third column. Now in third row and third column, what are the elements we have? R3 will be, R3 will be A, comma B, comma C, comma D, and C3 will be A, comma B, comma C, comma D. So when you take the Cartesian product of R3 cross C3, we get A, comma A, comma B, A, comma C, A, comma D, then B, comma A, B, comma B, B, comma C, B, comma D, then C, comma A, C, comma C, C, comma B, C, comma C, C, comma D. Then you have D, comma A, D, comma B, D, comma C, D, comma D. So that means what? They the new R what we find will be what? R4. R4 will be what? It will be all A, B, C, D, A, B, C, D. it will be all as 1 1. Therefore we can write, we can conclude this as, since we got all there is a root for all the elements, we can write, conclude it as, uh, the shortest path. So here it is a transitive closure, so hence the answer what we found is a called as transitive closure, hence it is proved. Okay, so no need of doing for fourth row and fourth column, because when you take fourth row and fourth column we'll get the same answer, so hence we stop for R3 step. So we'll move on with the next question. Here we have, derive the recurrence relation for the quick sort and merge sort. Quick sort relation is nothing but is a sorting algorithm that work by selecting a pivot element, partitioning the array into two sub-arrays, and recursively storing those sub-arrays. Let's denote the number of elements in array as n. Now, in each step of quick sort, we partition the array, which take the linear time on uh, after on. After partitioning, we recursively sort two sub-arrays, one with the element smaller than the pivot and the other with the element larger than the pivot. The recurrence relation for quick sort is derived as follows. So here we divide partitioning the array taken as on times. Conquer, we recursively sort two sub-arrays, each connecting roughly half of the original array. So the time complexity to sort each subarray will be t into n by 2. That is half of the time which will be given. Putting this step together, the recurrence relation for quick sort can be written as t of n will be t of n by 2 plus t of n by 2 plus 0, that is on. So yeah, it is how many times we have t of n by 2? It is 2 times. So t of n will be 2 times of t of n minus n by 2 plus on will be the derivation for the recurrence relation of quick sort. So moving with the next one, we have a merge sort. What is a merge sort? Merge sort is another sorting algorithm that works by dividing the array into two halves, sorting each half and then merging the sorted half back together. Again, let's denote the number of elements to be n. Now, in the step of merge sort, what we do, we divide the array into two equal half and recursively sort each half. After sorting the half, merging them together in the time of on. The recurrence relation for merge sort is derived for as follows. So here we will divide, splitting the array into two half takes a constant time. So conquer, we recursively sort two sub arrays, each containing n by 2 elements. So why we are taking n by 2? Because we are dividing into half. So the time complexity to sort each subset will be t of n by 2. So putting this step together, the recurrence relation for merge sort can be written as Tn equals 2 times of Tn by 2 plus On. So hence it is a, merge sort recurrence relation. Moving on with the next question, we have question number 17. What is the solution for recurrence relation? An equals An equals solution for an equals 5 n, it is actually a n minus 2 minus 6 a n minus 1, it is minus 2, minus 2, where the condition a naught will be 1 and a1 will be 0. So here, let us take rearrange this elements. We get an minus 5 an minus 1 minus 6 an minus 2 equals 0. Now let us take an as capital A dn. So totally a dn minus 5 a dn minus 1 minus 6 a dn minus 2 equals 0. So now divide by ADN minus 2, we get, if you divide ADN minus 2, ADN minus 2, ADN minus 2, we get A and A get cancelled, D will be D square minus 5, A and A get cancelled, we left out will be D minus 6, and this will all get cancelled till is 0. So now find the factor for 6, it will be 2 3s are 6, minus 2 minus 3 will give you minus 5. So D minus 2 and D minus 3 will be equal to 0 are the roots. So the roots are, D will be 2 and D1 will be 2 and D2 will be 3. So here the roots are real, the roots are distinct and real. So general formula will be AN equals C1 D1n plus C2 D2n. You can call this as equation 1. Now substituting the value of d1, we get an equals c1, a is 2 power n plus c2 3 power n. Now substituting the values of the condition what they have given, we have given a naught is equals to 1, that means n is equals to 0. Now a naught, substituting in equation 2, n is equals to 0, we get c1 of 2 power 0 plus c2 of 3 power 0. Anything raised to the power of 0 is 1. So we get a naught is 1, so 1 is equal to c1 plus c2. Then we'll take the second condition they have given, a1 is equals to 0, means n is equals to 1. So yeah, second one will be a1 will be c1 into 2 into 1 plus c2 into 3 into 1. So it will be 0 equals 2c1 plus 3c2. Now solving this, you can call 3, this you can call 4. Solving 3 and 4, solving 3 and 4, equation 3 and equation 4, we get equation 3 and equation 4, we get c1 plus c2 equals 1, 2c1 plus 3c2 equals 0. So we can take here substitution method, or you can elimination method. If I want elimination method, I should multiply by 3. So it will be 2c1 plus 3c2 equals 0. So 3c1 plus 3c2 equals 3. So now if I subtract, if I change the sign and subtract it, this will get cancelled. 3 minus 3 plus 2 is minus c1 equals minus 3. Minus and minus get cancelled. C1 equals 3. So now substitute the value of this in equation 3. We get 1 plus 3, 1 equals 3 plus c2. So c2 will be 1 minus 3. So c2 will be minus 2. So now we got c1 and c2 value. Substitute back in equation 2. Substituting the value in equation 2, what we get? We get as an will be equal to c1 is 3, 3 into 2 to the power of n plus c2 is minus 2 into 3 to the power of n is the final answer, final solution. Then moving on with the next question, we have find the number of solution of x1 plus x2 plus x3 plus x4 is equals to k, where x1, x2, x3 and x4 are integers with x1 greater than or equal to 3, x2 lesser than or equal to 1 and greater than or equal to lesser than or equal to 5, greater than or equal to 1, lesser than or equal to 5, x3 is greater than or equal to 1, less than or equal to 4, and x4 is greater than or equal to 1. So to find this, to find the number of solutions for the equation with the constant, we can use the inclusion and exclusion principle. This principle allows us to count the total number of solution while considering the conditions on each variable. So we will break the given condition. So it is first condition is x1 greater than or equal to 3, x2 is greater than or equal to 1, less than or equal to 5, x3 greater than or equal to 0, less than or equal to 4, x4 greater than or equal to 1. Now when you take y1 equals x1 minus 4, we can simplify this problem into introducing a new variable. Let me take y as x1 minus 4. So here to count for the beginning of x1 greater than 3, y2 we will take it as x2 minus 1. x2 minus 1 to account for x2 being greater than or equal to 1. Then y3 will be x3 to need to adjust. Y4 will be x4 minus 1 to account x4 begins greater than or equal to 1. So we got the y1, y2, y3 and y4 values. So here write it y1, y2, y3 and y4. Add the values k1 plus 4 minus 1 minus 0 minus 1 will give you k1 into 6. So the new condition for the variables are y1 is greater than or equal to 0, y2 is greater than or equal to 0 and less than or equal to 4, y3 will be greater than or equal to 0 and less than or equal to 4, y4 will be greater than or equal to 0. This is a class problem of counting the number of non-negative integer solutions to a linear equation with upper and lower bounds on the variable. The formula to be calculated for number of solutions for this type of equation is given by the Starts and Bars formulas. So here we have number of solution will be n plus r minus 1 chooses r times. So where n is the total number of variable in the case 4, r is the number of variable minute 1, since we have 4 variable y1, y2, y3, y4 and choice represent the binomial coefficients. So now the number of solutions for the equation is y1 plus y2 plus y3 plus y4 is k1 minus 6 is number of solutions. We can take it as 4 plus 3 minus 1. So here total number of solution is 4 plus 3 minus 1. Choice is 3. So 4 plus 3 minus 1. So it will be how much? 7 minus 1 will be 6. 6 choice out of 3. So it will be 6 C3. 6 C3 will be how much? 6 factorial means 6 into 5 into 4 divided by 3 into 2 into 1. So it will be 3 2s are 6, 6 get cancelled. So 5 4s are it is 20. Therefore, the number of solutions of the equation with the given condition is 20. So here next question is using mathematical induction prove the formula for the sum of finite number of the terms for the geometric progression. So here they have given so let me take this as p of n min plus n plus 1. N plus 1 is a plus ar plus ar square plus ar power n equals ar n plus 1 minus a divided by r minus 1. So here let me put n equals n minus 1. So if you substitute n equals n minus 1, we get p of n minus 1 plus 1 is a plus ar plus ar square plus goes on till ar n plus minus 1 equals a is common. If you take common, it will be r n minus 1 plus 1 minus 1 divided by r minus 1. So further simplification if you do, you get a r minus 1 plus 1 cancel, minus 1 plus 1 cancel. So it will be r minus r to the power of n minus 1 divided by r minus 1. Taking it minus common, we get a into 1 minus r power n divided by taking common 1, it will become 1 minus r. So minus and minus cancel, so it becomes a into 1 minus r power n divided by 1 minus r. So now that is pn will be a plus ar plus ar square plus goes on till ar n minus 1. Now put n is equals to 1. So if I put n is equals to 1, we get a plus ar square plus ar n is 1 minus 1 equals a 1 minus r 1 divided by 1 minus r. So 1 minus r cancel. So it will be a r to the power of 0 equals a. Anything raised to the power of 0 is 1. So it will be a equals a, that is LHS is equals to RHS. Therefore P of 1, therefore P of 1 is true. P of 1 is true. Now the next step we will take it as put n is equals to k. So P of k will be a plus ar plus ar square plus goes on till plus ar k plus 1 k minus 1 equals a into 1 minus r power k divided by 1 minus r. Now therefore p of k is true. Now we shall prove we shall we shall prove p of k plus 1 is also true. K plus 1 is also true. So let me take n is equals to p of k plus 1. So p of k plus 1 will be a plus ar plus ar square plus goes on till ar k minus 1. We have to add the next term of this, that will be p of ar to the power of k. So whatever I am adding here, the same term should be added to the LHS, that will be a into 1 minus rk power k divided by 1 minus r plus ar power k. So now taking LCM for both the sides we get, and simplifying we get 1 minus r will be a into 1 minus r power k plus a into rk into 1 minus r. Finding the LCM, and that means it will be cross multiplication. So removing the bracket we get a into 1 is a minus a into rk is a power rk, a r power k plus a r power k into 1 is a r power k minus a r k power is 1 means k plus 1, it is k plus 1 divided by 1 minus r. So here this and this get cancelled, we get a minus a r power k plus 1 divided by 1 minus r. Taking a as common we get 1 minus r k plus 1 divided by 1 minus r. Therefore p of k plus 1 is true for all positive integers of for all positive integers. Therefore p of k plus 1 is also true. Is also true. So yeah, the next question is color the given graph using the red, green and blue so that the two adjacent vertices has the same color. Has these no two vertices has the same color. So here they have given a b c d e f. They are four vertex and 1 2 3 4 5 6 7 8 edges. They are 6 vertex and edges are 8. 1 2 3 4 5 6 7 8 edges are there. So yeah, in this process red color we will be using in the first, green color we will use in the next, and finally we'll use blue color. Assigning red to a, green to b and red to c and green to d as follows. We will arrange it: a red and b is green, again a is c is red and d is green. So now E can be colored with only blue and assigned blue for F. So we'll be assigning blue for E. Now now we have stuck because F cannot be colored with any of the color. Now we cannot color. If I color here red, it is adjacent here. If I add a green color, it will be adjacent to this. If I add blue, it will be adjacent to E. Therefore we have stuck here. So what we do, we backtrack to E and try changing the color at the node E. There is no other color that can be considered, and hence backtrack to D. Now we will see here, we'll go for E, and if you try with the E we will get the same problem. So again what we'll do, we'll backtrack to D and we will color it as blue. Now E can be colored with green, E can be colored with green, and F can be colored with blue, so that the arrangement which is there gives you what, two adjacent vertex. No two adjacent vertex have this integer arising from the congruency modulo 4. So when partitioning the integers based on the congruency modulo 4, it is essential to divide the integer into four separate set based on their remainder. When divided by 4, they 4, the four sets are the why it is into 4, the residue of 4 modulo 4 is 1 2 and 0 1 2 and 3. So it is 4 residue we get, so it will be divided into 4 cases. So when it is divided by 4, what we get 0, 4 by 4 is 0, 8 by 4 is 0, remainder. Whenever we take these numbers and divide by 4, we get the answer remainder as 0. Then it is modulo 1 modulo 4. Congruency of 1 modulo 4 means the numbers which we take and divide by 4, we should get the remainder as 1. So it will be the remainder as 1. That will be, yeah, if I take a 7, 7 is not divisible, so here we can take it as, so when we divide the numbers, and in the congruency of 4, we get this as minus 3, minus 7, minus 3, 1 and 5 and 9. So here if you congruency of integers congruent to 2 modulo 4 is, when you divide this, the remainder will be 2. So here if I take 6 and divide by 4, I get 4 ones are 4, the remainder is 2. So yeah, if I take, even here if I take the integer 5 for this one and you divide by 4, it will be 4 ones are 4, it will be remainder will be 1. So yeah, if I take for 3, the number if you take and divide it by 4, 4 ones are 4, the remainder will be 3. So these are the set of numbers. When we divide, we get the remainder 3. When we divide with 4, we get the number 2. When we divide, we get the residue 1. And when or the these are the four set of partition of the integer arising from the congruent modulo 4. So next one, the next question is detach. Find out the shortest path using the distart dis, ditch Dickstar's algorithm for below graph. So here it is you need to follow the steps. It is easy to complete this problem. It is a lengthy problem, but it is easy if you understand. So what is this? Now the shortest path of the node 1, we will be taking from the node 1 to all other nodes using the Dickstar's algorithm. Convert the above graph into the cost matrix C. So here we have just written the value 1 and 1 is 0. If you have no connection, it is 0. And 1 to 3, 1 to 2, it is 1 to 2, it is 4. 1 to 3, it is 4. So we have just written the weight of the given graph in the form of matrix. So here S is 1, we are taking the first node, and V vertices are 1, 2, 3, 4, 5, 6. We have six vertex. Let us take the vertex 1 be the source vertex. We will be taking now 1 as the source vertex. Now step 2, initialize D. We will take initialize of D, that will be, we'll call it as D2. Now in D2 what we are going to check is, we'll be checking for C1 of 2. We'll be taking C1 of 1 of 2. What is the value we have? 4. Then D3 will be C1 of C1 of 3. That will be C1 of 3 will be 4. Then D4 will be C1 of 5. 4 will be infinity. C1 of 5 will be 5 is infinity. C1 of 6 will be infinity. So D2 is nothing but considering the values of first place, second place, third place, fourth and fifth, sixth place. So yeah, find W and add it to the S. What is W? Now for all this D2, D3, D4, D5, D6, what is the minimum value we got? We got the minimum value is 4. Because 4, that is for D2 and D3. So we'll consider the lowest number, that will take it as W. That is W will be 2. Add it to the S. So S will become 1 comma 2. Formula for V will be V minus S, that will be V is 1 2 3 4 5 6 1 2. So if you cancel 1 and 2, we get a 3 4 5 6 for V. Now V will change to 3 4 5 6. Now we have to find the formula for dV will be minimum of dV into dW plus dW comma V. So what does this mean? It is D2 D3. Now we are going to consider for D3. D3 is nothing but minimum of, now we are calculating V is how much? First one is 3. Okay, V is nothing but 3. So minimum D3. D3 is what? D3. D3 will be D of 3. That will be 3 is 4. Then D of 2. D of 2 will be 1. That will it will be, already we have found for that will be 4, and plus C of 2 comma 3, that is 2 and 3, it is infinite. 2 comma 3, 2 comma 3 will be 3. See, it is 2 comma 3 will be 2. So yeah, 4 plus 2, so it will get 4 comma 6. That minimum is what? It is 4. Then you'll go for fourth one. What will be D4? D4 will be D4 comma d2 plus c of 2 comma 4. So d4 is how much now? Now you can take it for d4. D4 means what? D4 is infinity. We have already found here. D4 is infinity. D4 is infinity. We'll write that infinity. Then D2 is what we have got? D2 is 4. We are writing that 4 value. Then C of 2 comma 4 is infinity. 2 and 4 is infinity. So what is the minimum? Minimum is here infinity itself. Then for D5, D5 will be minimum of D5 comma D2 plus C of 2 comma 5. D5 is infinity, d2 is 4, and d2 of 5, d2 of 5 will be infinity. So again the minimum is infinity. Similarly you will find for d6. So for all these values, we got it as 1, s is 1. It is first one is 4 4 infinities we got. For second one is 1 comma 2, iterations we are doing. 1 comma 2, w will be 2, where we got 4 4 infinity infinity and infinity. Now moving on with the next one. If you take this graph, that is if you take these values again and you substitute here, we'll just so what will be the minimum of this? It is 4. So where it is 4, it is for d3. D3 is 4. So what we'll do, we'll take this as w. So w is 3. Now add it to s. So s will become 1 2 3, and v will be v minus s, that will be 1 2 3 4 5 6 minus 1 2 3. If you cancel 1 2 3, we get 4 5 6. Now we have to find it for 4 5 and 6. The formula is same. dv will be minimum of dv comma dw plus dw comma v. If you repeat the steps, the minimum here is 7, the minimum will be 5, and the minimum will be infinity. So then next iteration we got 1 2 3. The values we got is 3, and w is 3, and d2 is 2, d2 is 4 and 4 as it is. For d4 we got 5, and d5 we got 5, and d6 is infinity. Then we'll consider with the next step again dw for, and add it for s. Now what will be the least value of this value? 7 5 and 8 infinity. 5 is the minimum value. Where is 5? It is for d5. So w will become 5. Now s will be 1 2 3 and 5, and v will be v minus s, that is 1 2 3 4 5 6. 1 2 3 5, if you cancel, v will be 4 comma 6. Now we'll repeat the same formula and we'll find for d4 and d5 value, d6 value, and we'll substitute in the bracket, in the box. Now then again repeat the same step, find the w and add it to the s. Minimum value of 4 and 6 with d4 and d6 will be 3. So w will be 3, w will be for 3 means it is for d6. So w will become 6. Now add it to s, it will be 1 2 3 5 and 6, and minusing with v, we get v as 4. Now find it for v4 in the same formula, we get minimum value as 2. So here therefore the shortest distance for d2 is 4, d3 is 4, d4 is 2, d5 is 5, and d6 is 3. So this is the shortest path that we have found for all the every vertex. So hence it is proved by detached. It is easy if you prepare and practice. Just go through with the problem and try to solve the problems. Okay. Thank you students for watching. I'm going to update one more video on this second model question paper. You can just like